Good morning, chemistry class. It's Mr. Ball here. Today, it's April 1st. To remind you, nball at steelacademyedu.org if you have any questions. Today, we are actually going to do something really fun. We're going to create your own nuclear power plant. Now, before you do this, I want to make sure you have goggles. I want to make sure you have safety gloves and a radiation vest. Because, radiation's harmful. Make sure your whole family does too. Especially for your own at-home nuclear power plant. You don't want to have a nuclear meltdown on your house. That could be very, very bad. Actually, April Fools. We're not going to do that. We're going to talk about crystal lattice. Sorry, I had to do that. I know I'm getting a couple groans right now already from you guys, and I appreciate that. But when we talk about a crystal lattice, this is really talking about ionic bonding and how things arrange the way they are. So I want you guys to think of sodium chloride. So sodium chloride, as you remember, NaCl. Na makes the positive one. Cl makes the negative one. And so when they align, and you can see up here, sorry, I just bumped the camera there. This is how they're going to align. It's tough to show you in 3D because I only have a 2D piece of writing material here. So what I did is I made two different sheets. So if you can tell, I have Na and Cl lining up how they would. You see how they're all next to each other, but they never touch another one of the same charge. For instance, positive, negative, positive, negative, positive, negative. And that goes the way throughout. It's almost like a Sudoku with chemical elements. Now on the other one, I actually created what it would look like on the sheet behind it. So when you look at this, if you superimpose this onto this, and all superimpose means is you put one thing on top of the other. So this sodium would line up with this chlorine, that's a positive and a negative lining up together, and they attract each other. So that's why something like sodium chloride, all these strong attractive forces from being a positive ion and a negative ion, that's why they have such strong bonds. And with those strong bonds, they form that solid of sodium chloride or table salt. That's how we know it. That's why you can see like the little kind of squarish crystals. They're in that crystal lattice. So hopefully that makes a little bit of sense to you right there. Next thing I'm going to add on to this real quick is we know there's such a thing as salt water. If you have a sore throat, a lot of people will actually gargle with salt water. So when it comes to that, we're going to erase a little bit with my trusty sock here. Take this NaCl. We're going to grab a cup of water. We got the water up to here. We're going to place it into here. So when we place NaCl into there, we know it actually dissolves. There are a couple reasons why it dissolves, but we're not going to get into that really right now. All you have to know is NaCl dissolves. So when it dissolves, this solid, I'm going to put a little S in parentheses. When we add it to water, it forms an A plus and Cl minus. Both of these are what we call aqueous. So aqueous means in solution. If you're wondering how that's spelled, Aqueous. This would be a very good Scrabble word. 7 letters, pretty solid. So when it comes into here, it disassociates. So that means little Na pluses, little Cl minuses. So you got the Na, Cl, Na, Cl, 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 Na, Na, Na. And what happens here is with all of these, you'll notice they aren't in the lattice anymore because they're aqueous. They're floating around the water. They move freely. But a cool thing since there is charges in the water, positive and negative charges, you're going to be able to conduct electricity with this. So if you were to put like if you were to charge it somehow with a battery electrode, it would actually have some. Oh, look at that. That was actually pretty good. It would have some electricity to it. Things with ions in water and charged ions are going to have an electrical charge to it. There's a different electrical charge for all of them, but all electricity is the ability for electrons to move freely. So it does have an electrical charge. All right, guys, that's all I got for you today. We covered quite a few vocab words. Watch this 2 or 3 times to really get those vocab words down and to learn a little bit about it. Next week, well, Friday, we'll have something else, probably a little fun activity. Still working on that. See if I can do it properly for you. If not, we'll go back to the book a little bit. But Friday, I'll actually put out the work for next week and what we're going to get into. So just want to say thank you to everybody. Have a good day.